This is the second video in the topic on straight line graphs. In this video we're learning to look at rules, tables and graphs and how they are related to each other. You may recall from our last video that we plotted some points, and when we connected the lines they formed the letter W. Now in this topic we're going to look at the relationship between the X and Y coordinate, and if we can see a pattern on the page then we should be able to write a rule that explains that relationship. However, we're not really looking for a pattern that would form a letter or a picture such as a house, a snail or a butterfly. We're trying to look for a particular shape. Now not all graphs are straight lines, so I'm going to draw a few graphs that may have a different shape. This is called a parabola. You can see by the curves and that both sides are symmetrical. Here's a different shape again. So I can make a variety of shapes depending upon what I type in. It may be that I raise it to a power, it may be that I multiply it by a particular number, it may be that I add or subtract something. However, there are a variety of rules, and every time I see a particular shape I can have an idea of how that rule needs to be written. However, the ones that we're going to concentrate most in this topic is going to be straight line graphs. The base straight line graph is just y equals x. Goes to the origin and it heads up on a 45-degree angle. Alright, so let's start looking at how we plot points using a rule. Now a rule is an equation that connects two or more variables. Now in our case we are most often going to be using x and y. Now a rule that produces a straight line when we graph it is said to be linear, and you can see the word line in the word linear. Now linear rules are most often written with the y as the subject, which means that y is on the left hand side of the equal sign and is on its own. So now let's look at how we can plot these points and form a graph. Alright, first of all, graphing from a rule. There are several ways that you can go about this, but the way we're going to start with is to construct a table of values. Now a table of values could be horizontally or vertically. The book generally uses a horizontal table, but you may wish to do yours vertically. Now the way that we fill in this table is we need to complete the table by substituting x into the rule. So here we have a rule here, y equals x plus 1. What I'm going to do now is I'm going to take, when I get it to work, I'm going to take the value -3 and I'm going to place it into the rule. So y equals -3 plus 1, which equals -2, and I put that down where y is. I do the same for the next value of x. If x is worth -2, I place that into the rule and I'm going to get -1, and I continue along. Take -1, place it in the rule, I'll get 0, 1, 2, 3 and 4. Hence I've completed my table of values. If I was doing with the vertical table, I'd do exactly the same thing. Take the -3 in the x column, substitute it into the rule, and I would get -2. Take -2, substitute in the rule, -1, 0, 1, 2, 3 and 4. Now sometimes we'll see these tables as a listed set of ordered pairs. So here we have 5 brackets, -3 was -2, -2 was -1, -1 was 0, 0, 1 and 1, 2. And we can continue on with the rest of the pairs. Alright, so once we've completed our table, we would then need to go and plot them onto a graph. Alright, let's look at plotting some points on the graph. Now obviously I've already drawn a graph here and I've chosen an appropriate scale. What I do need to do is just complete it a little bit. Make sure I have arrows on my x-axis. Make sure it's labelled as x. Alright, let's have a look at the rule y equals 2x plus 1. What we need to do now is take the x value, -3, and substitute it into the rule. So y equals 2 times -3 plus 1. Well, 2 lots of -3 is -6, plus 1 is -5. So that's my y value. I do the same with -2. 2 lots of -2 are -4, plus 1, -3. 2 lots of -1, plus 1, -1, and then it will go on 1, 3, 5, and 7. So now I've completed my table of values. What I need to do now is take that table of values and place it onto the graph. So my first point that I want to plot is going to be -3, -5. So that's my first ordered pair. So -3, -5 down here. Take my second pair, -2, -3. My third pair, -1, -1. And I continue on 0, 1. That doesn't look right, does it? Now, let's take that one away for a second. 0, 1. Now, why did I know it wasn't correct? I knew it wasn't correct because it didn't fit the pattern. So my next point is 1, 3, 2, 5, 3, 7. So now I take my ruler and I connect the points. I place an arrow on each end to indicate that it goes on forever. All I am doing is plotting some of the points that appear on this line. Alright, now for the second one, y equals 4 minus x. I want you to pause the video, complete the table yourself, and then fill in the graph. So stop the video now, I'll come back to you in a moment. Alright, let's see how you've gone. I'll take the first value of -3. I'm going to substitute that in. So my y value is going to 4 take away -3. We learned earlier that 2 negatives are going to make a positive in this case, so therefore I'm going to end up with 7. I do the same for -2. I'm going to get 6, 5, 4, 3, 2 and 1. And now I need to plot those points. So my first point that I'm going to plot is -3, 7. So -3, 7 right up here. -2, 6, -1, 5, 0, 4, so on and so on. I then take my ruler and connect the points. Once again, place an arrowhead on the end. I continue it past the points because I know that this goes on forever. Alright, I want you to try the last one. Once again, pause the video, try y equals 3x plus 2. Off you go. Alright, let's see how you've gone. If y equals 3x plus 2, I'm going to use once again -3. I'm going to do a little bit in my head this time. So 3 times -3 is -9, plus 2, -7. 3 times -2 is -6, plus 2, -4. -1. 0, it's going to be nice and easy. 3 times 1, plus 2, 5, 7, should say 8, 9, well that's going to be 11. Now in fact, if you're having difficulty, particularly with negative numbers, you don't need to start on the left hand side with -3. You could start with +3, 3 times 3 is 9, plus 2 is 11, then +2, and you'll actually see that there's a pattern starting to emerge. Alright, let's see if I can plot this on the graph. My first point I'm going to plot is -3, -7. But once again, you could start on the right hand side with 3 and 11. Then 2, -2, -4, -1, -1, 0, 2, 1, 5, 2, 8. That'll do for the moment. Once again, draw a line through. Arrowheads. Now, I've used colours to indicate which graph is belonging to which rule. However, if you didn't have different colours, you may in fact need to write on the actual graph that is the rule y equals 3x plus 2, just so that people know. Right, well done. Alright, last part of this exercise. Sometimes we like to know where a point actually lies on the line. Now this is a little bit like Pythagoras when we wanted to find out whether a triangle was in fact a right angle. So what we do in this case, we have a rule, y equals 3x. What we want to do is we want to substitute the point into the rule, and if we end up with a true statement, then that point belongs on the rule. If we end up with a false statement, then that point lies somewhere other than on the line. So let's try the first one. We have y equals 3x. Now remember that the first number is x and the second number is y. So I'm going to replace the x and y, substitute, with the numbers 1 and 3. So 3 equals 3 times 1. 3 equals 3. That is a true statement. Therefore, the point 1, 3 lies on the rule. Let's try the second point, -2, 4. We'll do the same thing. Let's start off with the rule, y equals 3x. I'm going to replace the x and the y. So the y value was 4, the x value -2, and end up with 4 equals -6. Now that is a false statement. Therefore that point does not lie on the line. Alright, now go and open up your study outline. Have a look at exercises 9b to exercises 9.2 and complete those.